writing equations of lines in slope-intercept form. So right now you should be on lesson 5. Okay, we skipped over lessons 3 and 4, so make sure you're on lesson 5. And it says one skill that we need to become fluent in is writing equations, creating equations of a linear function. So we need to be really quick at that. The form that we're going to focus in on right now is the one that you're most familiar with, the slope-intercept form. So it says, given a linear function f of x, it can be expressed in equation form. So f of x equals y, we know that, okay, that's just our function notation, equals mx plus b, where it says the two parameters are m, meaning your average rate of change or your slope or your change in y over change in x, and the second parameter is your b, or your y-intercept of the line. Okay, so two pieces of information we need in order to write an equation of a line. It says, consider this linear function on this graph. Determine an equation in our y equals mx plus b form, our slope-intercept form for this line. So if we need those two parameters, we need to find out the slope and we need to find out the y-intercept. So that y-intercept is right there, which is 2. And then let's pick another point on that line to be able to do the rise over the run, which is our slope, and we're going to go up 3 and right 2. So that's a slope of 3/2. So we've got our two parameters, so now let's just fill in those pieces that we need. So the equation to this line is 3/2 x plus 2. So if I were to label this, that's exactly what I would put on my graph. Now it says test your equation for the value of x equals 2. So test our equation. So let's see if it's true. So when x equals 2, according to my graph, where x equals 2, right, let's change colors. When x equals 2, y is 5, correct, according to our graph? So let's see if our equation, if we wrote our equation correctly. So we want to know what's y when x is 2 plus 2. Well, 3/2 of 2 is 3 plus 2 is 5. Y equals 5. Is that true? 2, 5? Yes, absolutely. We put in, our input was 2 and our output was 5. Yes, that does sit on the line. So we wrote our equation correctly. It says when the y-intercept is an integer, okay, such as what we just got done doing, our y-intercept was 2, it's fairly easy to get the exact relationship between x and y. Now let's look at another graph where the y-intercept is not an integer, meaning it doesn't cross at a nice, neat location here on that y-axis. So it says find the equation of the linear function in slope-intercept form, and then we want to test when x is -4. So I'm going to write down, we still want y-intercept, or excuse me, slope-intercept form. So we still want our y equals mx plus b. And so let's see. We know we need the y-intercept and we know we need the slope, but we determined we really can't tell what the y-intercept is, but we probably can pick 2 points off of our graph and find the slope. So it's up 1 and back 3. Up 1 and back 3, that rise over run means it's 1 over -3. Or you certainly could say -1 over +3. Those are equivalent, okay? Either one is acceptable. So we just picked 2 points off of that graph. Let's go with this one. Let's see how this graph can help us to find exactly what that y-intercept is. Well, this point here that I just put in blue is the point 2, 1. Well, that 2, 1, that's an x, and that 1 is a y, right? So in my equation, I have a y. They gave us the slope. We found an x. That leaves us with one unknown in our equation, which is what we're looking for. So if my y, if I pick that point, 2, 1, and now I'm going to put it back into my y equals mx plus b. So y is 1 equals, the slope is -1/3. The x that we just used is plus 2, and then plus b. Now we've got an equation where we only have one unknown, where we can solve for b. So, excuse me, 1 equals negative 2/3 plus b. So I'm solving for b here. So I've got to add 2/3 to both sides. And lo and behold, I have b all by itself. So 1 plus 2/3 is 5/3. Let's keep that to that improper fraction. Don't go to the mixed number, okay? So we've got our two parameters now that I need to write my equation. We found the slope by the rise over run. Then we picked a point off our graph, 2, 1, and used it in our equation to come out with that y-intercept, which was not an integer, was not easy to find, but we could find it algebraically. So now, finally, we can write the equation. So my equation is y equals negative 1/3 x plus 5/3. So that would be the equation I would put on that line. Okay, let's go ahead and turn the page. We also need to be able to find the equation of a linear function if we know 2 points that lie on the line. Notice this means we have to determine the value of the 2 parameters we need with 2 pieces of information. So remember, keep in mind, always to write the equation of a line, we need the slope, that's the first parameter, and we need the y-intercept, that's the second parameter. So if I want to, sorry about that. So I want to take my 2 points that I'm given here, 2, 5, and 5, 17. So I certainly could take those 2 points and I could graph them. Okay, I could plot 2, 5, and I could plot 5, 17, and then I could connect to those 2 points and do the rise over run, and I could see where the y-intercept is as well to be able to write the equation of this line. But let's do it algebraically. So I've got to find my slope, and we know that's the change in the y over the change in the x. So my change in my y, I'm going to say 17 minus 5 over 5 minus 2. You could flip the order of this. Okay, we talked about that in class. That's okay. I'm going to stick with this right now, and that's going to be 12 over 3, which then simplifies to 4. So I've got my first parameter. I've got my slope. Now I've got to find my y-intercept, the b. Okay, we don't want to find the b. We just did it in the last question. So I've got an x and a y, and I've got another x and another y. You pick. Doesn't matter which one you pick. If you pick this first point, 2, 5, that's cool. If you pick the second point, I just lost my cursor. Where'd it go? There it is. If you pick the second point, 5, 17, that's fine too. I'm probably going to pick 2, 5 just because they're smaller numbers to deal with. So y equals mx plus b. The y from this point, that's the one I chose to work with, is 5. The slope we just found was 4. The x from that point that I chose to work with is 2. And I've got to find the y-intercept. Solving this, I get 5 equals 4 times 2 is 8 plus b. And if I solve for b, I'd have to subtract 8 from both sides and get a negative 3. Well, there's my second parameter that I need to write the equation. So my equation that would connect to the point 2, 5, and 5, 17 would be y equals, whoops, let me erase that, y equals 4x minus 3. Okay, now let's do it again. Okay, same idea. We've got 2 new points, negative 2, 5, and 2, 3. So again, I could graph those 2 points, connect the 2 dots, do the rise over the run to find the slope, and then eventually find the y-intercept. But I want to focus in on doing this algebraically right now. Change in y over my change in x. That's my first parameter I need. I need my slope. So 3 minus 5 over 2 minus a minus 2, which is 2 plus 2. Okay, I went 3 minus 5, 2 minus a minus 2, which is plus 2. So that gives me negative 2 over 4. When I simplify, whoops, negative 2 over 4, that gives me a negative 1/2. So there's my first parameter, my slope. Now what do I need? What's my second one? Okay, you should answer, we need the y-intercept. So again, we use our equation, y equals mx plus b. Pick one of these 2 points. It doesn't matter. I'm probably going to go with 2, 3 just because it doesn't have any negatives. So my y is 3, my slope is negative 1/2, and my x is 2 plus the b I'm looking for. 3 equals negative 1/2 times 2 is negative 1 plus b. Solving for b, I'm going to add 1, and I get 4 equals b. Again, there's my second parameter. There's the second piece of information I need to write the equation of this line. Y equals, I don't know why that keeps moving, negative 1/2 x plus 4. Okay, let's do it a couple more times. Hopefully by the 4th time, it will be super easy for you guys. All right, so what do I start with? I start with my slope, change in y over the change in x, and I don't know, I might go this way. 11 minus a minus 4, which is 11 plus 4, and then negative 1 minus 4. Notice I changed the order, but it doesn't matter. I stayed consistent. I went from the first point to the second point for the y's, and then back to the first point to the second point for the x's. Still going to get me to that same answer. 15 over negative 5, which simplifies to negative 3. Is my slope, first parameter. Now let's go in and let's find the b. So y equals mx plus b. I guess it doesn't matter which, again, it never matters which point we pick. I think I might pick this one, this first one, this negative 1, 11. So my y is 11, my slope is negative 3, and the x is negative 1 plus b. 11 equals 3 plus b. Subtract, and we get b equals 8. There's my second parameter that I need. And now let's just substitute y equals mx plus b. Okay. And this last one of this type, my slope, 19 minus 4 over 12 minus 3, which is 15 over 9, okay, which then simplifies by 3, so that's 5/3. Always try to simplify your slope. Okay, so there's my slope. Now let's find the y-intercept. So, I don't know, I think I might pick this first point to work with, that 3, 4. So 4 equals mx plus b. 4 equals 5 plus b, and b ends up being negative 1. There is your second parameter, and plugging that in to our equation, we end up with y equals 5/3 x minus 1. There's our last equation. Okay, so now let's take it and apply it. A car is traveling along a straight road. After 1 hour, the car is 72 miles from Chicago. After 3 hours, the car is 188 miles from Chicago. Determine an equation for the distance d the car is from Chicago after 8 hours if the relationship between d and h is linear. So what are my points? 1, 72, and 3, 188. Okay, so we're doing the same thing. So the change in the y over the change in the x. So that is 116 divided by 2, and that can simplify to 58. There's my slope, okay, or my average rate of change. And then I've got to find that y-intercept. I think I might pick this first point and say 72 equals 58 times 1 plus b. 72 equals 58 plus b. Subtract 58 from both sides, and we end up with b is 14. So my equation, okay, it says determine an equation for the distance. So d equals 58, okay, 58h plus 14. Okay, there's our equation. Right? Nice job.